Unit 4, problem number 4. Idealize the box section shown in figure into an arrangement of direct stress carrying booms positioned at the four corners and panels that are assumed to carry only shear stresses. Hence, determine the distance of the shear center from the left-hand web. Okay, first thing we have to idealize this section and we need to determine its shear center. So idealizing, we convert the stringers or stiffness into booms. Booms is a concentrated area. Let me assume this is 1, 2, 3 and 4. The first thing we need to determine booms. Determine the booms. The booms formula P is equal to thickness of the panel section into breadth divided by 6 into sigma, if it is 1, sigma 2 divided by sigma 1 plus 2. This is the Booms formula. Okay, for first section, so first for a boom 1, it is connected with the panel 1 2 and panel 1 4 and also the area of the boom. So the B1 will be equal to stringer area plus panel 1 2 plus panel 1 4. The stringer area from here, so we have seen the stringer area, this one, this L bend, so I can write it here. So it is a 60 cross 50 cross 10. So let's assume this is 60 and this is 50 and thickness is 10. Okay, first we have to consider area of the stringer. So I will divide into two rectangle. One is this one. The area is 60 into 10. Plus now I'm going to consider this one, this region. So the length here it is 60 minus, sorry, this one, no, 50 minus 10. The area will be 50 minus 10 into 10, that is 40 into 10. So here for stringer area I can write 60 into 10 plus 40 into 10 plus, now the booms area for the panel 1 2. For 1 2 the thickness is 10 and the breadth is 500, so it will be 500. Okay, so it will be for a value of t here, t will be 10 and that will be 500 divided by 6. Now sigma 2 and sigma 1. Sigma 2 and sigma 1 are directly proportional to the distance from the centroid. So it is a symmetrical section. The centroid will be atmosphere. So the distance is 150. So sigma 1, so this is point 1. So sigma 1 will be 150 and sigma 2, this is sigma 2, it will be 150. So it will be 150 divided by 150 plus 2 plus for panel 1/4 the thickness panel 1/4 this is panel 1/4 the thickness is 10 the length is 300 so it will be t equal to 10 and b equal to 300 divided by 6 then it will be sigma 4 divided by sigma 1 so sigma 4 is this length so this length is a minus 150 so minus 150 divided by 150 sigma 1 plus 2 okay when you solve this when you do the arithmetic so it will be b1 equal to 4000 mm² you will get so here the section here the section is a symmetry therefore b1 equal to b4 equal to 4000 mm². So similarly if you do for b2 equals stringent area so and then panel 2 1 plus panel 2 3 so that is this stringer 2 is connected with the panel 2 1 and panel 2 3 so here the stringent area is 50 cross 40 cross 8 50 cross 40 cross 8 this is 50 this is 40 and the thickness is 8 the first I will divide into two rectangle so one the first area is 40 sorry first is 50 cross 8 plus this length that is 40 minus 8 40 minus 8 is 32 so 32 into 8 that is the single area that is the single area is 50 cross 8 plus 32 cross 8 the formula for panel 2 1 is TDB divided by 6 2 1 right sigma 2 in the bottom sigma 1 in the top plus 2 for panel 2 3 TDB 6 sigma 2 in the bottom sigma 3 in the top plus 2 so it will be 50 cross 8 50 cross 8 plus 32 cross 8 plus the thickness of panel 2 1 panel 2 1 is 10 and the breadth is 500 so it will be 10 into 500 divided by 6 into sigma 2 is 150 sigma 1 is 150 plus 2 plus panel 2 3 panel 2 3 this is panel 2 3 so your thickness is 8 and breadth is 300 so that is 8 into 300 divided by 6 then sigma 2 is 150 and sigma 3 is this distance, that is minus 150. So minus 150 plus 2. So on resolving this one, we will get a B2 equal to 356 mm square, and also it is equal to B3 because of the symmetry. Okay, so now we will determine the shear flow. It's a closed section, then shear flow formula will be Qs equal to minus Sy divided by Ixx summation of n equal to 1 to n. So area, that is boom's area, into the radial distance plus Qs naught. So now we have to determine Ixx for the idealist section. Ixx equal to summation of a into h square. So h will be y dash minus y. So Ixx, so for a boom 1, so the area is B1, that is 4000 mm square, 4000 mm square into h square. So h is the distance from the centroid. So distance from the centroid is from here to here, that will be 150 square. So here a B1 and B4 are symmetric. B1 and B4 are symmetric, so I can multiply by 2. Similarly for a B2, the area is 3556, which we have found earlier, into distance is same 150 square, and it is symmetric, so B2 and B3 are equal, so I will multiply 2. So Ixx equal to Ixx equal to, we'll get 340 into 10 power 6 mm power. So this is our Ixx value, and now we will determine the Q12. So first we will make a cut in Q12, and we will start determining the Qs for the open section. So Q12 will be equal to 0, as it is a starting point of the open section, so it comes as a 0. So now Q23 will be minus Sy Ixx B2y, so it will be minus Sy unknown. So Ixx is 340 into 10 to the power 6 into B2 is 3556 into y is 150. On resolving, you will get minus 1.56 into 10 power minus 3 Newton per mm. So now Q23, sorry, this is Q23 and we'll have a Q34. So Q34 will be Q23 minus SY IXX B3Y. So Q23 will be minus 1.56 into 10 power minus 3 into SY, sorry, into SY minus SY divided by 340 into 10 power 6 into B3. B3 is 3556 into minus 150. So it will be minus 1.56 into 10 power minus 3 SY equal to plus 1.56 into 10 power minus 3 SY. So it will be equal to 0, that is Q34 equal to 0. So now Q41 equal to Q34 minus SY divided by IXX B4 into 1. So Q34 is 0, therefore minus SY divided by 340 into 10 power 6 into 4000 into minus 150. So on resolving this one, we will get a 176, sorry, 1764.7 into 10 power minus 6 or 1.764 into 10 power minus 3 SY. The unit is Newton per mm square. So now we have determined for a open section. So for closed section, Qs equal to Qb plus Qs comma 0 or Q0. So therefore Q12 equal to the value is 0 plus Q0. It will be Q0. So Q23 equal to minus 1.57 into 10 power minus 3 SY plus Q0. Q again Q34 equal to 0 plus Q0 equal to Q0. Q41 equal to 1.77 into 10 power minus 3 SY plus Q0. So now our ultimate aim is to determine the Q0. So we have to identify a Q0 first. For that we use a twist formula which we have seen in the third unit. The twist d theta by dc twist equal to, or beta equal to 1 by 2ag into integral of q ds dt, or you can write it as beta equal to ql 2ag t. So this is the formula. So here in our case, the vertical load is acting on the shear center, so the twist will be 0. Therefore beta equal to 0, which is equal to ql divided by 2ag. So here what we do, here g is the material property, okay, and these parameters are a constant. We consider, we will say ql divided by t. So we take these parameters to this side, it will be 0 into 0, 0. So ql divided by t equal to 0. So we have already found the q, and here the length is a shear length of each section or a panel. So for example, first we will take a 0 equal to q12. We will take q12 into L into T. That is, so I'm saying for example, see. So first we will take the first panel 1 2 QL into L divided by T. So first panel 1, what is our QL? QL is Q0. Q0 will write. Q0 will write. Now L and T for panel 1 2. So panel 1 2, our length is, this length is 500, L is 500 and T is 10. Okay, so it will be 500 divided by 10. Similarly, we have to do it for all the 4 sections. So I can write 0 equal to panel 1 2, it is Q0 into L 500 divided by 10. Now panel 2 3, the length is 300 divided by the thickness is 8. Q 2 3, it is minus 1.57 into 10 power minus 3 plus Q0. Now panel 3 4, it is 500, the length is 500 divided by 10. So the Q34 is 0 plus Q0, that is Q0, plus now panel 4 1, the length is 300 divided by thickness 10, and the shear Q41 value is 1.77 into 10 power minus 3 SY plus Q0. Here I missed SY. So on simplifying this, we will get a relation Q not equal to 0.034 into 10 power minus 3 SY. So this is the Q naught value. Now we are going to add it in the equation which we have found. So Q1 12 equal to Q34 equal to, sorry, Q34 equal to Q naught we have already determined, which will be equal to 0.034 into 10 power minus 3 SY. Similarly, for Q23, it is equal to minus 1.57 into 10 power minus 3 SY plus Q naught. It is 0.034 into 10 power minus 3 SY. So it will be equal to minus 1.536. Similarly, for a Q41, it will be 1.777 into 10 power minus 3 SY plus Q naught, which is 0.034 into 10 power minus 3 SY, which will be equal to 1.804 into 10 power minus 3 SY. This is Q41. So now we have determined the values of shear force values of each section. Now we are going to determine the shear center value. So for this we are going to take a moment at this point, because in the problem question, the problem statement, they have said determine the distance of the shear center from the left hand web. So we are taking the moment at this point. So for this point, the panel 1 4, that is boom 1 and 4, lying on the section. So we will not consider for the moment. So for our moment, we will consider panel 3 4, panel 2 3, and panel 1 2. So for shear center, the force is acting on the shear center. So I will take a moment along moment on the left web. So it will be Sy into distance, it will be minus Sy, and the panel 1 2, force 1 2 into perpendicular distance, it is 150, plus force section for section 2 3, force is F23 into the distance 500. Similarly, for section F34 into distance 150. Actually, so we know tau is equal to F by area. That is F by area, I can say shear length into thickness. Shear length into thickness. So F equal to tau into T into shear length. Shear and ds I can write it as a L, that is Q into L. So instead of this force, I can write it as a shear flow into the panel length. So it will be minus Sy into E equal to, for F12 instead of F12 I will write Q12, that will be 0. Q12, what is Q12?
Q12 is 0.034 into 10 power minus 3. 0.034 into 10 power minus 3 SY into the length. So 1 to length is 500 into 150. So moment. Next QF23, it is a minus 1.536. Sorry, I missed 1.536. 10 power minus 3 SY minus 1.536 into 10 power minus 3 SY. The shear length is 300, distance is 500, then plus F34 plus F34, it is F34, F3 is 0.034, 0.034 into 10 power minus 3 SY. Shear length will be 500 into 150. So everywhere SY is common, so we'll cancel SY. So our E will come 224.95 mm, or you can write E equal to 225 mm. This is our shear center value for the given section. Thank you.